Okay, honors physics, let's go over some of the key points that we learned today about parabolic motion. It's the motion of a projectile. In the horizontal direction, we're going to say that there's no acceleration because the force of gravity is the only force that pulls downward, and the horizontal forces are not pulled downward. They're only in the x direction. So we could say that oh Lord, let's try this one more time. We could say that we use only the equations for constant velocity. So we'll use basic equations. We're not using the equations that we use for constant acceleration because there's no acceleration, okay? However, in the vertical direction, the object is always accelerating at negative 9.8 meters per second or 9.8 meters per second downward, right? So this is a constant acceleration. So please do use the Fantastic Four formulas. Our kinematics equations. A is going to be equal to little g. It's going to be negative 9.8 meters per second squared. That is going to be true for all of our vertical components. Time, though, is the real MVP. It's our most valuable variable when solving projectile motion problems. Since time is a scalar, it will be the same for both the x and y direction. So it's really a nice bridge. It's the key to bringing these two components together. Now, when we talk about maximum height, a few points to note. Maximum height is the maximum displacement in the y. At that moment, our velocity in the y is 0. There is no velocity in the y direction at the maximum height. The time, however, is going to be half of the total time. So half of the total time of flight. This could also be said to be our hang time, or the total time that we're in the air. The total time that it takes to reach our height is half of the total time. Okay, how do I solve problems then? Because tomorrow we are going to jump right into equation usage and solving problems using different components. So draw a well-labeled diagram. It actually will help you to draw out the path of the projectile. And make two columns. One for x and one for y. That might look like this. A table with the horizontal values on one side and the vertical values on the other. We'll have to be careful to check our units and do any conversions if necessary. And the last part is, you're pretty good at this. Use the guess method. Make sure you list the givens, the unknown, put your equations, substitute the values in, and solve. So tomorrow we'll talk about this. Projectile motion problems can generally be sorted into one of three types based on the launch angle and whether the ground is level. So tomorrow we'll start you out with type 1 and type 2. In type 1, we say those are angle launched. We get our standard parabola from that because we're at an angle to the ground. Type 2 are horizontally launched. That's like if you're on a cliff and you let the object go off the cliff. And you probably guessed what type 3 would be. It's almost like a hybrid. If you're from a height and you're from a cliff and then you launch it from an angle and let it go off of the cliff, that would be type 3. So it's a projectile launched at an angle from an unlevel ground. Oop. Oh. Come on, touchscreen. Sheesh. All right. That was it, quick and painless. Be ready to go tomorrow. If you guys had questions regarding what we did today, especially Q2, A, B, and C, I've got some of the answers here. We're breaking them apart and using our trig functions. Question 5 was a little more challenging. On my solutions here, though, I forgot to use the little -1 here. It was an inverse tangent on that last one. All right, and see you all tomorrow.